Welcome. In this video, I will talk about two topics, Fermat's little theorem and cryptography. In cryptography, I will talk about seizure cipher, shift cipher, and affine transformation. So let's start first with the Fermat's little theorem. What is the statement? If P is prime, I highlight it, P is prime and A is an integer not divisible by P, then a to the power p minus 1 is congruent to 1 mod p. This can also be written as a to the power p is congruent to a mod p. To make sense of this, I am going to solve three problems which will help us to get better idea about this theorem. But before I take this problem, I want to quickly recall 2-3 results of modulus that we already have studied in our previous videos. So the first result I want to recall that if A is congruent to B mod M, this implies that A to the power K is congruent to B to the power K mod M, right? And this also implies that K into A is congruent to K into B mod M, right? So we are going to use these two results to solve this problem here. So how to solve this? We have to evaluate 7 to the power 222 modulo 11, and this statement or this question can also be asked like what is the remainder when 7 to the power 222 is divided by 11, because we remember from our previous videos that A mod M is equal to what? It is the remainder which we get when we divide A by M. So how to apply the Fermat's little theorem? So here we are going to take the integer A is equal to 7, and the prime number that I am going to take is P is equal to 11, and clearly 11 does not divide 7 because that is the requirement that A is an integer not divisible by P. Then A to the power P minus 1 means what is A here? 7. What is P here? 11. So 7 to the power 11 minus 1 is congruent to 1 mod 11, right? And this can be seen as what? 7 to the power 10 is congruent to 1 mod 11. Now I want 7 to the power 222, and we have 7 to the power 10, and we also know this result. So using this result here, I hope you will agree if I take 22 power here of 7 to the power 10 and 1 both, right? The reason being that I want to make it 7 to the power 222, but because we have 10, we can't make it 222, but certainly we can make it 220 by taking the 22 power. So this will give me what? This will give me 7 to the power 220 is congruent to 1 mod 11. And now I want 7 to the power 222. So using this result here, what we can do? We can multiply both sides by 7 square. So 7 to the power 220 into 7 square is congruent to 1 into 7 square modulo 11, which can be written as 7 to the power 222 is congruent to, and 7 square is 49 modulo 11. Now I know that if I am working with modulo 11, this integer 49 can be reduced and it can be written as what? 7 to the power 222 is congruent to 5 modulo 11. I hope you got this point, because what is 49? If I ask you what is 49 modulo 11, so if you divide 49 by 11, 4 is the quotient and 5 is the remainder. So the remainder is 5 if you divide 49 by 11. So we have just got the answer that 7 to the power 222 is congruent to 5 modulo 11. It means what? That 7 to the power 222 modulo 11 is equal to 5. So this means what? That if I divide 7 to the power 222 by 11, the remainder will be 5. Okay. So let us take a few more problems to understand this better. Now look at this problem. Evaluate 5 to the power 2003 modulo 7. So here A is 5, prime P is 7, and 7, the prime P, does not divide 5. So all the requirements of Fermat's little theorem is fulfilled. So using that, I can write 5 to the power 7 minus 1 is congruent to 1 modulo 7. So this gives me what? This gives me 5 to the power 6 is congruent to 1 modulo 7. Now I want the power to be 2003. So what we can do, if you divide 2003 by 6, you will get the quotient as 333 and the remainder as 5. You can check it yourself. So I am writing 5 to the power 6 to the power 333. That is congruent to 1 to the power 333 modulo 7. And this will give me what? This will give me 5 to the power 1998 is congruent to 1 modulo 7. If I take the power 334, it will be more than 2003. So that is why the quotient here is 333. But I want it to be 5 to the power 2003. So I hope you are smart enough to see that now in both sides we are going to multiply 5 to the power 5. So here I will get 1 into 5 to the power 5 modulo 7. Now this can be written as what? This can be written as 5 to the power 2003 is congruent to 5 to the power 5 modulo 7. Now ladies and gentlemen, one thing that we are getting here is 5 to the power 5, and evaluating 5 to the power 5 modulo 7 is not a difficult task. We can take 5 to the power 5, which is 3125, and then we can divide it by 7, and whatever is the remainder that I will get can be taken here. But suppose we don't want to do that. We want to use modulo further. So the modulo can be applied further over here, and I'm explaining it in this side so that you understand. See, if I have to calculate 5 to the power 5 modulo 7, then I can consider like 5 is congruent to minus 2 modulo 7. I hope you agree. Why? Because 7 divides 5 minus minus 2. 5 minus minus 2 will be 7. So this can be seen as 5 to the power 5 is congruent to minus 2 to the power 5 modulo 7. And 5 to the power 5 is congruent to minus 2 to the power 5 is minus 32 modulo 7. So again, I hope you remember how to take minus 32 modulo 7. So those who have watched the previous video, I hope they remember that the minus 32 can be written as 7 into minus 5 plus 3. Because remainder, if I am taking modulo 7, the remainder can take its value from 0 to 6. So we have to always make it positive, right? From 0 to 6 means 0 is also possible. So here 7 into 5 is minus 35 plus 3 is minus 32. So what we got in the end? We got in the end 5 to the power 5 is congruent to 3 modulo 7. Yes. So continuing the original problem, I can write what? I can write 5 to the power 2003 is congruent to 3 modulo 7. Because 5 to the power 5 modulo 7 is 3, so 5 to the power 2003 is congruent to 3 modulo 7. So what is the answer now? The answer is that 5 to the power 2003 modulo 7 is equal to 3, and that is what I was looking for. I hope this is clear. Now let us move to this problem here and try to prove that 3 to the power 3002 is congruent to 4 modulo 5. So again, to apply the Fermat's little theorem, I can take A as 3 and P as 5, and we can clearly see that 5 does not divide 3. So the statement tells that 3 to the power p minus 1, that is 5 minus 1, is congruent to 1 modulo p, that is 1 modulo 5. So here I can write 3 to the power 4 is congruent to 1 modulo 5. And I want 3 to the power 302, so I can take 3 to the power 4, and to the power 75 is congruent to 1 to the power 75 modulo 5. So it becomes what? It becomes 3 to the power 300 is congruent to 1 modulo 5. And I want 3 to the power 302, so I hope you are smart enough now that you can multiply by 3 square in both sides. So you will get 1 into 3 square modulo 5, right? And 3 square is 9, so 9 modulo 5 is 4. So this becomes what? 3 to the power 302 is congruent to 4 modulo 5, and that is what I wanted to prove. So basically it gives me what? It tells me that if you divide 3 to the power 302 by 5, the remainder will be 4, and that is what we wanted to prove. Now in the end, this problem I am leaving for you to solve, right? And after solving this problem, put your answer in the comment section, and also let me know that whether you are able to understand the Fermat's little theorem or not. So moving next, we are going to talk about the cryptography part. As you are all aware that in today's time, when most of the communication are happening through digital network, it is very important that we need to secure our message, because when we are transmitting something and if someone intercepts that message in between or during the transmission, they will be able to create a lot of trouble in our life. Suppose we are using internet banking password, and here I entered my password and someone just got to know my password through some hacking system. Then possibly he will be able to take out all our money from our accounts. Similarly, if you are even sharing the personal message with someone and someone is checking the message in between, that will create a lot of trouble in our life. So you must have noticed in WhatsApp also they claim that our messages are end-to-end encrypted. It means what? That no one other than the sender and the receiver is able to see the message. So in cryptography, one first aspect of cryptography is encryption. In encryption, what happens? Whenever a message is there, we first try to encode the message by using some process or system. So once we encode the message, that message can be transmitted, and if someone receives that message in between, it is very difficult for him to get to know that what is the actual message that was sent, unless he is aware about that what kind of approach has been taken to encrypt the message. So in this video I will be talking about three small process of encryption and decryption, and the first one is the seizure encryption. So what is seizure encryption process? Before I talk about seizure encryption process, let us quickly recall that what do I mean by the set Zn. So in set Zn, we take all the remainders which we get when we divide any integer by n. So the remainder that we can get is 0, 1, 2 up to n minus 1. As we know that in English alphabet or in English language, there are 26 alphabets. So if I write Z26, what it will be? It will be a set which contains all the integers from 0 to 25. I repeat my argument that since we know that in English language there are 26 alphabets, so I can use a corresponding set that is Z26 which contains the alphabets from 0 to 25. So in seizure encryption process, suppose we have to translate a message, and suppose we have to translate the message love you, right, using the seizure encryption process. Means we have to encrypt the message using the seizure encryption process. So it involves multiple steps, and in the first step what we do, we replace each of the alphabet by a corresponding number. What is that corresponding number? So in Z26 we have the numbers from 0 to 25. So we associate the alphabet A with the number 0. We associate the alphabet B with the number 1 and so on. And the last alphabet Z is assigned the number that is 25. So when we have to encrypt this message, first of all, I am going to change all these alphabet into the corresponding numbers. So here L stands for 11, so I write 11. O stands for 14, so I write 14. The V stands for 21, so I write 21. E stands for 4, so I write 4. And Y stands for 24, so I write 24. O stands for 14, so 14. U can be replaced by 20. So this is the step number 1, that we change all these alphabets into corresponding numbers which I have listed here. In the next step, when we are using the seizure encryption process, we use this function, that is P plus 3 modulo 26. So we add 3 to each of the number and then we take modulo 26. So if we have 11 and if I add 11 plus 3, I will get 14, and 14 modulo 26 will be 14. 14 plus 3 will be 17. 17 modulo 26 is also 17. 21 plus 3 is 24 and 24 modulo 26 is also 24. And 4 plus 3 is 7. So this is the first thing. Now this list of numbers. So 24 plus 3, now it is 27, but 27 modulo 26, the remainder is 1, so I will write 1. Now we have 14, 14 plus 3, 17, 17 modulo 26 is 17. And then we have 20, so 20 plus 3 is 23. Now what we do, we change this into alphabets. So now 14 stands for O, 17 stands for R, 24 stands for Y, 7 stands for H, and 1 stands for B, 17 stands for R, and 23 stands for X. So the original message was love you, and using the seizure encryption process, we have changed the original message into this message. So this is the process of seizure encryption. Let us take one more example here to make more sense of it. Suppose we have to translate the message using seizure encryption, and the message is meet you in the park. So what is the first step? That each of the alphabets meet you in the park has been replaced by the corresponding number, and I would suggest you that you should verify that whether it is correct or not, and I already have listed down this, right? So what you basically have to do, that you can count that what is the location of M in the English language alphabet, and then subtract 1 from this. Like A comes at first place, then we write 0 for A because 1 minus 1 is 0. Similarly, C comes at the third place, so for C we use the number 3 minus 1, that is 2. So here we first change all these alphabets into the corresponding numbers, and then each of the numbers are replaced by this function, that is P plus 3 modulo 26. So 12 becomes 15, 4 becomes 7, 4 becomes 7, 19, 22. It is 24, so 24 plus 3 is 27, and 27 modulo 26 will be 1, because we have to take the remainder when we divide 27 by 26. So this becomes 1, 14 plus 3, 17, 20 plus 3, 23, and so on. In the end, we translate this message to get the encrypted message. So 15 stands for P, 7 stands for H, 22 stands for W. So what we get, the original message was meet you in the park, and after encrypting using seizure cipher, we have got this message. Okay. Moving ahead, we can even decrypt the message. Like once first process is encryption. So you sent this message to someone, meet you in the park, and the encrypted message that the person received was this message. Okay. Now how will the person who received this message will get the original message? So to get the original message, he has to use the function, the inverse function, that is f inverse p is equal to p minus 3 modulo 26, right? So this process of getting the original message is known as decryption. So to understand it, let us go back to the example that I took here. Now let me change the color so that you don't get confused. This was the original message, love you, and when I used the seizure encryption, this message was changed into this. Now suppose someone receives this message, so how that someone will get the original message? So he will also follow the process. He will first write 14 for O, you can see, then 17 for R, you can see that R stands for 17. For Y he will write, so he will write this number, okay, he will write this number, and then he will subtract 3 from each of the numbers. So 14 minus 3 is 11, 17 minus 3 is 14, 24 minus 3 is 21, 7 minus 4 is 7 minus 3 is 4, 1 minus 3 is minus 2, so he will get minus 2, right? He will get, if you he received 1 minus 2, so sorry, 1 minus 3 is minus 2, and what is minus 2 modulo 26? So minus 2 modulo 26 is 24. This is sometimes a student make the mistake here when they get a negative number. So don't make the mistake, because if I am getting minus 2 and if I have to get minus 2 modulo 26, so basically minus 2 is written as what? It is written as 26 into minus 1 plus 24. The remainder is always positive. So for 1 he will get 24, 17 minus 3 is 14, 23 minus 3 is 20. Now once he will change it to this list of numbers, then he will get the corresponding alphabets and he will get the original message, that is love you. So there are two processes in cryptography. One is encryption, other is decryption. And in seizure cipher, the function that we use to encrypt the message is fp is equal to p plus 3 modulo 26, and to decrypt we use the message p minus 3 modulo 26. Okay. Now the next thing that we want to talk about is generalization of seizure cipher. So some of you might be thinking that why we are taking the function fp is equal to p plus 3 modulo 26. Right, because originally when this seizure was using this process, he used the term 3, but this 3 can be replaced by any term k. So we can use a function that is fp is equal to p plus k modulo 26, right? Modulo 26, right? So this cipher which we have used is known as shift cipher, right? So you can just read it once to get a better idea that we can generalize the cipher. For example, instead of shifting the numerical equivalent of each letter by 3, we can shift the numerical equivalent of each letter by any number k. So suppose we have defined this fp is equal to p plus k modulo 26. Such a cipher is called shift cipher, and the decryption can be carried out using the inverse, that is f inverse p is equal to p minus k modulo 26, where the integer k is called a key. So I hope there is nothing special about this. In seizure cipher I was using 3 as the key, and in shift cipher I can take any integer as the key, right? So to make sense of it, let us look at this example here. That suppose we have to encrypt the plain text message. This is the original message, that is stop global warming, using the shift cipher, and the cipher that the key that we are using is 11. So what we have to do, first of all, in the first step we have to change all these alphabet into the corresponding letter. And how we have to change that, we already have explained that S will be in place. S stands for 18. Just quickly look at this, that here we have this, that S stands for 18. So here also we are going to change the message. What is this? Yeah, similarly if you talk about T, T will stand for 19 and so on. So we are getting a string of letters. So stop global warming will be changed into this. There is no change here, means all these alphabets are replaced by the corresponding term of Z26. right? Z26, this would be Z26. Now we have to apply the shift cipher, that is P plus 11 modulo 26. So 18 plus 11 is 29 and 29 modulo 26 is equal to 3. So this 18 becomes 3. 19 plus 11 is how much? 30, and 30 modulo 26 is equal to 4. So this becomes 4. 14 plus 11 is 25 and 25 modulo 26 is 25. So this is 25. 15 plus 11 is 26 and 26 modulo 26 is equal to 0. So we got it 0. Similarly, all the numbers are changed using this function, and in the end we translate it back to the alphabet. So as you have seen in the list, D comes at 4th place, so it will be assigned the value 3 because we start the count from 0. Similarly, the 4 is replaced by E, 25 is replaced by Z, 0 is replaced by A, and all these numbers are replaced by the corresponding alphabet of English language, and what we get is this message. So the stop global warming is changed to this a string when we are using the shift cipher, that is K is equal to 11. I hope you got this. Now suppose I just look at one more problem where we want to decrypt the message. So suppose I have received one such message, and it is already known to me that the person who has encrypted the message has used the shift value, that is K is equal to 7. He has used the key as 7. So what is the process? The process is that this is the original message. First we translate it to the element of Z26. So when we translate it to the element of Z26, it should be written like this, Z26. We obtain the a string like this, because L stands for 11, E stands for 4, W stands for 22. So we get this message. Now we have to use the inverse function. So inverse function is what? F inverse P is equal to P minus 7 modulo 26, because we are decrypting the message. So we subtract 7 from each of them. So if we subtract 7 from 11, we get 4. If we subtract 7 from 4, we get 4 minus 7 is equal to minus 3. And minus 3 modulo 26 is how much? Minus 3 modulo 26 is equal to 23. So we get 23, and so on. So all the like here we have 7. So 7 minus 7 is 0, and 0 modulo 26 is 0. So this is the new set of a string that we get, and then what we do, we translate it back to the alphabets. So 4 stands for E, 23X stands for X, 15 stands for P, and so on. So the message which was received like this has been decrypted in this form, which is suggesting you that experience is a great teacher. Yes, this is a good quote also, that experience is a good teacher. Okay. So the next thing that we are going to talk about is affine transformation. So we have used Caesar cipher and shift cipher. In Caesar cipher, I was using the function fp is equal to p plus 3 modulo 26, right? And in shift cipher, I was replacing this 3 by any integer k. But we can make the function slightly more better, or we can enhance our security by using a function that is fp is equal to ap plus b modulo 26. So in spite of using a simple function like p plus 3 or p plus k, I can use a better function or more enhanced function, that is ap plus b modulo 26. One thing that we need to keep in mind, that whenever we are using this function to use affine transformation, we must have to ensure that the GCD of a and 26 is equal to 1. Means this a and 26 should be relatively prime. If they will not be relatively prime, it will be very difficult to decrypt the message, because we want the message to be encrypted and also at the same time we want to ensure that anyone who receives the message should be able to decrypt the message as well, and that will be possible only when you take A and 26 as relatively prime, or if their GCD is equal to 1. So what I'm actually trying to tell you that if you use any random function, that certainly may not necessarily be an affine transformation. For example, if suppose some student is using the function like fp is equal to 4p plus 7 modulo 26, so this will not be an affine transformation. Why? Because this 4 and 26, if you take their GCD, this GCD is equal to 2, which is not equal to 1. Right, so that is why we can't take this as an affine transformation. But in this problem that I have taken here to explain the concept, the function that I have taken is 7p plus 3 modulo 26. So our a value is 7, and if I take 7 and 26, if you look at these two numbers, they are relatively prime. So this is a right kind of affine transformation. And the question, and this kind of question is usually asked also, that if I have to suppose replace the letter k using the affine transformation where we are using this function, what will be the representation for k? So the process is that we all know that k will be assigned the value 10, right? I hope you remember this. Just I want to show you one more time. It is very difficult to go back and forth, but still you see that for k we use the number 10 because k comes at 11th place, so its value that we use is 10. Now first step is that change the alphabet k, and k is changed to 10 in the number form, and then we use this function. So what is f10 function? So function is 7 into 10, that is 70 plus 3, 73, and modulo 26. So 73 modulo 26 is 21. I hope you remember this, because 73 can be written as what? It can be written as 26 into 2, that is 52 plus 21. So the remainder is 21. And now 21 stands for what? 21 stands for V. So the original letter was K, which is changed by V, and this is the encrypted message. Okay. Can we take one more problem? So suppose I move to the next page, and suppose I take one more alphabet. Suppose I take one affine transformation. Fp is equal to, suppose I take 11p plus 3 modulo 26, and I want to use this function to encrypt the alphabet E. So how will I encrypt E? We know that E stands for 4 because A, B, C, D, E, it comes at 5th place. So the corresponding number is 4. Now what is F4? So F4 is 11 into 4 plus 3 modulo 26. So what will be its value? Its value will be 11 plus 4 is 44 plus 3 47, and 47 modulo 26. So I think the remainder is 21 here. Yeah, yes or no? 7 minus 6 is 1, and 4 minus 2 is 2. So 47 can be basically seen as 26 into 1 plus 21. So 21 stands for what? Let us go to check the list. That 21 stands for V. So using this transformation, the alphabet E is changed to V. Okay. Now the question arises is, and this is important because most of the students understand the encryption, but they find it challenging to decrypt. So suppose I ask you that someone who receives the message V, how he will get back to E, how he will decrypt the message. So what he will do, he will take V and he will change the V to the corresponding letter, that is 21. And he will use the function what? He will use the function F inverse and F inverse P function. So basically he will be doing like this, that 21, that is the value of Fp, is congruent to 11p plus 3, 11, let me correct it. 11p plus 3. 11p plus 3 modulo 26. This is what he will start with. That since he knows that this is the function that has been used to encrypt the message, so he will take this equation that 21 is congruent to 11p plus 3 modulo 26, and it can be solved. So how it can be solved? So if 21 is congruent to 11p plus 3, means 18 is congruent to 11p plus 11p modulo 26. So I subtracted 3 from both sides. I hope you understand. Basically, what does this mean? This means that 26 divides 21 minus 11p minus 3. So this also means that 26 divide 18 minus 11p, and that is what I have written, that 18 is congruent to 11p modulo 26, which can be written for our convenience as 11p is congruent to 18 modulo 26. And this is a congruence relation. In one of the previous video, I have discussed in detail that how to solve the linear congruence relation. So just for the quick revision, let us solve this also, because it will help us to revise the previous thing as well. Right, and I am going to use this space here because I don't want to move to the next page. So how to solve this linear congruence? So first of all, we note, I am writing the solution here in this side. So first of all, we note that 11 and 26, they are relatively prime. The GCD of 11 and 26 is equal to 1. So it means that we can find the inverse of 11 modulo 26. And I will multiply by the inverse of 11 modulo 26 in this congruence. So how to find the inverse of 11 modulo 26? One way is to use hit and trial. Another way is to use the Bezout coefficient. So 26 can be written as 11 into 2 plus 4. Okay. And then 4 can be written as, sorry, the 11 can be now written as, let me change it again. So what we will do, we will write 11 is equal to 4 into 2 plus 3. Now 4 can be written as 3 into 1 plus 1, and now this 3 can be written as 1 into 3 plus 0. Okay, now what is the way to calculate the Bezout coefficient? So I will start with 1 here. So 1 is equal to 4 minus 3 into 1, and then 4 minus, for 3 here I will write 11 minus 4 into 2 and into 1. I hope you remember that process. Now what is this, gentlemen? It is 4 and minus minus plus, so 4 into 2 plus 4 into 1, so 4 into 3 minus 11 into 1. And now I have to replace this by 4 by 26 minus 11 into 2 into 3 minus 11 into 1. So in the end, what I got? 26 into 3, and here 11 into 6 and minus 11 into 1, so plus 11 into minus 7. So you can verify 26 into 3 is 78 and minus 77, so that is equal to 1. So it is correct. So we have got two Bezout coefficients, and those Bezout coefficients are what? 3 and minus 7. So whether 3 is the inverse, that we can verify. So if I multiply 11 into 3, it is equal to 33, but 33 is not congruent to 1 modulo 26. So 3 is not the inverse. So what is the inverse? The inverse is minus 7. So to solve the linear congruence, I hope you remember that once you get the inverse, you multiply it by the inverse in both sides. So 11 into minus 7 will become minus 77, and which will be equal to P. I hope you understand it. Minus 77 can be written as what? It, because it is the inverse, so certainly it will become 1. But just to understand it, minus 77 can be written as 26 into minus 3 plus 1. So this, if I multiply it by minus 7, it will become P. and 11 into 18 into minus 7. So how much is that? Minus 126. And minus 126 modulo 26 will be how much? How will I get this? So you can see we can write 26 into 5. 26 into 5 is minus 5. 26 into minus 5 is minus 130, and plus 4 I will get minus 126. So minus 126 modulo 26 is basically 4. So I get congruent to 4 modulo 26. So it means what? That P is congruent to 4 modulo 26. So now I can take the value of P is equal to 4. And P is 4. So the original message which was received as V, and then it was changed to 21. And solving this linear congruence, we have got 4, and 4 stands for E. So the encrypted message will be E. I hope there is no confusion. I think it has become slightly clumsy here. But let me repeat the whole argument once more time. One time more. Once more time. So what I'm saying is that given any alphabet, change it to the corresponding number. Then use this function, that is 11p plus 3 modulo 26. Because I have taken this function, whatever affine transformation you take, you change it accordingly. And after that, you translate the message into back into the alphabet terms. So this is what we have done. The decryption process requires some more effort, because once someone receives the message V and he want to decrypt it, then he has to solve this linear congruence. Which linear congruence? That since V stands for 21 or 21 stands for V, so I will solve 21 is congruent to 11p plus 3 modulo 26, and this actually is nothing but 18 is congruent to 11p modulo 26, which can be written as 11p is congruent to 18 modulo 26. And solving this linear congruence I have discussed in very detail in one of the previous video, but here also I have narrated the whole story, that first I have to find the inverse of 11 modulo 26. So to find the inverse, we have used the Euclidean algorithm, and then we have written the greatest common divisor, that is 1, as a linear combination using the Bezout coefficients. So Bezout coefficients we have received are -3 and 3 and -7. So we know as a fact that 3 or -7 will be the inverse. So we verified that -7 is the inverse, and then we multiplied it by -7 in both sides here in this equation. So what we got is P is congruent to 4 modulo 26. So basically the solution is P is equal to 4, and 4 stands for E. So we got the original message E. So this is all about this video, and if you are following the content, and especially this Fermat's little theorem and cryptography, so one of the topic I wanted to discuss. So if you are new to the channel, certainly you should subscribe it and share with all your friends, because here you don't get the quick solution certainly, but you get the very comprehensive detail of any topics. So thanks for watching. Have a great day.